Okay, so we're on 5.4 for just a moment. Like I said, we're not going to talk about it a ton. It's just something that I like to touch on, but we don't actually do indirect proofs, not just because we're skipping proofs for a bit this year, but we don't actually make indirect proofs on our own. We talk about how to do it, and we talk about the first step, but that's kind of it, okay? So an indirect proof, I understand we haven't really done a whole lot with proofs anyway, but I'm still going to talk about it. An indirect proof or proof by contradiction. Sometimes in math, something's easier to prove. So something in math is either true or false, right? Sometimes it's difficult to prove that it's true. It takes, like, in college I had like a 20-page proof. Obviously we're not doing that in here, but it took a lot to prove that it was true. But proving that the false statement was incorrect was easier than proving that it was true. Let me say that again. Something's either true or false in math, right? Sometimes proving that it's true is harder than saying that the false is not true. Do you guys see what I'm saying? Okay, so this is what a proof by contradiction is. Sometimes it's quicker to prove the opposite is incorrect, which means that the opposite, the original, must have to be true. I hope that sort of made sense. So the first thing you do is you assume the conclusion is false. You say the opposite of what they were saying, right? And then you show that that assumption leads to a contradiction, which we're not doing. And the false assumption means the original conclusion is true. That's what I was trying to say, okay? So state the assumption you would make to start an indirect proof of each statement. So if they said line segment AB is congruent to line segment CD, we would say not congruent, right? So we're going to say line segment AB is not congruent to line segment CD. That's how we would start an indirect proof, but that's as far as we're taking it. So, okay? With this one, it says if 4x is less than 24, then x is less than 6. So this is something we didn't super talk about before. This is like our given, and this is our proof statement. So we're assuming the conclusion is false, okay? So the conclusion is this part, right? So I don't care what this part says. So instead of x is less than 6, I would say super close. Not just x is greater than 6. That doesn't include every possible greater than or equal to. Very good. Yeah. So x is greater than or equal to 6. Everybody says x is greater than 6, and then we're like, oh, just kidding. Neither one of those included 6, so I need the line. Does that make sense? If this one had the line, then mine wouldn't. So one of them has to have the line, right? Angle A is not a right angle. So what would we say? Angle A is a right angle. So even though you don't get the actual whole proof part because we're not doing it, you at least get how we would start them. Okay? And then triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. That's the new notes, isn't it? Yeah, okay. So we're not doing number 20 because we're not doing an indirect proof, right? So skip that. So we're on 5.5 now. Go ahead and get those 5.5 notes out. Sorry. I thought that didn't look right. So is everybody okay? You assume the conclusion is false. You say the opposite, right? That's about as far as I would ask, okay? So 5.5, these are normal notes. We'll actually do some examples here, okay? There we go, the triangle inequality. I'm going to say that again. Triangle inequality theorem, the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So if you look at your example, you've got a 3, a 5, and a 7 on your triangle, right? See the 3, the 5, the 7? Do I have that on here? I don't think so. I'll write it down then. So we've got a triangle with 3, 5, and 7. So if I take 7, 3, and 5. If I take any two sides and add them up, they have to be bigger than the third side. Okay? So like if I do 3 plus 5, it has to be bigger than 7. Is it? Is 3 plus 5 bigger than 7? Yeah, that's true. If I do 5 plus 7, the rule says that it's bigger than 3. Is that true? Duh, right? Because 5 and 7 are both bigger than 3. What have I not done yet? The 3 and 7? Is 3 and 7 bigger than 5? Yes, right? Can anybody think of a quicker way to do that instead of doing all 3 of them? How could I do this where I don't have to do all 3?
Just do the two smallest, and if it's bigger,
Very good. He just said take the two smaller lengths, and if it's bigger than the third side, then they're all going to be true, right? So this example, the two small ones, the small plus the middle, something like that, if it's bigger than the largest side, then they're all going to work because of what I just said, right? 5 and 7 are already bigger than 3, so I don't even have to check it. And then 3 and 7, 7's already bigger than 5 by itself, so I didn't really have to check it either. Does that make sense? So I'm going to write myself a note. I'm going to take the small side plus the medium side, and if it's bigger than the large side, then it's true. I don't have to check all 3. I can just check that one, okay? The small plus the medium has to be bigger than the large. You can check all 3 if you don't, bless you, if you don't remember the rule, that's totally fine. Just right here, Allie, thank you. You can check all 3, but you don't have to. If you can remember the rule, you can just do the one, okay? Anybody confused? All right. Is it possible to form a triangle with the given side lengths? If not, explain why. So in my opinion, the math is the explanation. It's either true or false. So on this one, let's just do the shortcut. What two sides would I add up? The 11 and the 16, and they have to be bigger than 21. What is 11 plus 16? 27. Is 27 bigger than 21? Yes, so it makes a triangle. I know that it's hard to wrap your mind around it not making a triangle. If we ever have time, I'll do this toothpick activity with you guys. Maybe I'll see if we have time for it. But I think people think if you have 3 lengths, it's going to make a triangle. But if you think about it, like if I make a length that's like 2 inches long and a length that's, I don't know, like 4 inches long, and I'm trying to connect these two, right? If this is, let's say this is like 10, then that didn't work, right? Like it's not going to connect. It's not going to work. So it's hard to explain by just making up numbers. But what we do is it's like toothpicks, and I give you so many, and you try to form a triangle, and sometimes it's literally not enough toothpicks to like connect the two sides together. Do you see what I'm saying? So just because you have 3 lengths doesn't mean it's going to make a triangle. Okay? All right, so on number 9, what 2 are we going to add up? The 2.1 and the 4.2, and it has to be bigger than 7.9? What is 2.1 plus 4.2? 6.3. Is that bigger than 7.9? No. So I put a slash through the greater than sign, and I say no. In my opinion, the math is the explanation. Okay? So 6.3 is not greater than 7.9, so no. Have I lost anybody? You guys okay? Okay. Find the range, okay, for the measure of the third side of a triangle given the measure of the two sides. That's going to bother me. Given the measures of the two sides. So for this, I'm just going to tell you how to do it, and then I'll go back and explain it. All you have to do is add these two together, and that's the highest number we can have, and subtract those two together, and that's the lowest number we can have. That's how we have a range. We say in between the two numbers that we end up getting. So even though it's easy math, I would show yourself the work because you're going to forget how we got that later. So I would say 5 plus 11 is what? 16. So there's one answer in a second. And then 11 minus 5 is 6. So the way we write that in math is like this. That literally says x is between 6 and 16. Or 6 is less than x is less than 16, or x is greater than 6 but less than 16. Those are all the same thing. Does that make sense? So the range of numbers that are possible to make a triangle here is anything between 6 and 16. So for example, not 6 though, right? There's no equal sign there. So if I take like 7, right? If I chose 7 as one of my sides, I would say, bless you, I would say 5 plus 7 is 12, check. That worked out, right? If I pick like 10, okay, I would say 5 plus 10 is 15, bigger than 11, check, right? If I picked 15, not 16, if I picked 15, I would say 5 plus 11 is bigger than 15. Do you see how that range, anything in between here is going to make it still work out to be a triangle? Is that okay? Okay. Obviously decimals would be fine too, I just didn't do that. So on this one, we're going to add them together and subtract them together. So 3.8 plus 9.2 is what? 13, good. And then 9.2 minus 3.8 is 5.4. So I write 5.4 less than x less than 13. If you're in Algebra 2 right now, this probably makes sense to you. If you don't have Algebra 2 yet, You can memorize how to write that if you'd like to. I can pull it apart and write it differently if you'd like. Basically, we always go smaller to larger, less, less. That means it's in between the two numbers. Is that okay? Okay. And then we're not doing a proof because we don't do that yet. Is that it? Yeah. Anybody have a question? Okay. Hold on one second.